So this was a weekly structure pop quiz 16. If you have any doubt or a question, one, any part, 1A, 1B. B1, 2, any doubt? Part C, C1, C2, any doubt? C2, 3, and 4, okay. So I will discuss part C. The beam in B rotates when the string is cut and a smaller block of a weight 2.4 Newton is projected through the air. Figure 2.2 shows the last part of the path of a block before it hits the ground. At point X on the path, the block has a speed of 3.4. So it's moving, so it has a kinetic energy. And it is at a certain height, so it will have also have a gravitational potential energy. Calculate the decrease in a gravitational potential energy, how much the gravitational potential energy decreases as it moves from X to Y. So the decrease in potential energy, it's mgh, which is the change in the height. So the gravitational potential energy will be mg and delta h. The mass of the block, the weight is given. So this mg is given to us 2.4. And what about the change in height? It's 1.8. So 2.4 times 1.8, that will give us how much energy will be lost. How much energy, the gravitational potential energy decrease, that's 4.3 joules will be there. 4.32 joules. The next part, so at this point, at point Y, which form of energy just before it hits? It already possess, because the total energy should be same. So if, at this point, how much is the kinetic energy? It will have, because the next part, we need use your answer to C1 and conservation of energy, determine the kinetic energy at Y. So at this point, it was having a kinetic energy and the gravitational potential energy. But at this point, it has only kinetic energy because it has height is 0. So we can, if I say this is kinetic energy 1, this is kinetic energy 2. So both the kinetic energy 1 and the gravitational potential energy has converted into the new kinetic energy. So we can say the new kinetic energy will be equals to the gravitational potential energy plus the kinetic energy 1. The gravitational potential energy, which we already calculated at this point, that was 4.32. Kinetic energy at the first point, the kinetic energy at the first point, it will be half mv square, where v is the speed at which it was moving. So it was moving at a speed of 3.4. So it will be half. The mass will be, because this is a weight is given, so it will be 2.4 divided by 9.8. That will be the mass. And then the speed square, the speed was 3.4 square. So this will give us the new kinetic energy at point Y, because the kinetic energy plus the gravitational potential energy has converted into kinetic energy. So we'll get the new kinetic energy, that will be the sum 5.73. So 5.73 joules of the kinetic energy is there. That's the total kinetic energy at point Y. Then state the variation, if any, in the direction of acceleration of a block as it moves from X to Y. When object is falling, it will have the two, like this is the projectile motion, so it will have the two component. It will have the horizontal component and it will have a vertical component. The horizontal component in a projectile, we assume that it is not changing, like there's no acceleration. Only what will happen, there's acceleration or deceleration in a vertical plane. That is due to gravity. So we'll mention here that the acceleration will be constant, which is downward, and there's no change in the acceleration. As like because we ignore any air resistance, that's why the horizontal component remain constant and the acceleration is remaining due to gravity. Acceleration is not, it's not whenever object is falling object never decelerate, it is acceleration is there and its acceleration decreases if there was a air resistance. If I drop an object from certain height, if there was no air present, if there was no air present, then the acceleration will be equals to gravity. But if there was an air present, then the acceleration of this object will decrease. But we will not say it will decelerate. Why we don't say it's decelerating? Because the speed of a falling object always increases. In the beginning, it will have less speed, but then the speed increases. So without air resistance, the speed time graph will be like this. With air resistance, the speed time graph will be a curve and eventually it reach a constant velocity we call as a terminal velocity. Same thing for falling object, a projectile without air resistance. This, if we want to vertical velocity component, so in the beginning, the vertical velocity at a certain height, it is 0. Then the vertical velocity start to increase as this is falling. And what about the horizontal velocity? If there was a horizontal velocity, it remain unchanged because the horizontal component does not change. So it will be a horizontal line. So acceleration, why it's not decreasing? Because in the question itself, it is mentioned air resistance is negligible. So on the figure, block passes point X at time Tx and Y at point Ty. We have to sketch the horizontal component as there's no air resistance to oppose the motion. So horizontal component will remain same. As I mentioned, numerical values are not required. So if they said numerical values are needed, then what you will write? As you can see, you can divide the velocity, like at this point, the speed was 3.4 and certain angle should be there. Angle is not given to us. So we can simply say that the horizontal component remain unchanged. If the graph was for vertical component of a velocity, because see this from X to Y, this is point X and this is point Y. It has some vertical velocity and it has a horizontal velocity. And when it is coming down, the vertical velocity increases. So if this was a vertical component of a velocity, will not start with 0, will start with certain velocity and then a straight line which shows it's a constant. If it was about vertical component. But because they asked for horizontal component, so it will be a straight line, horizontal line. When object is falling, the speed always increases. That's why it's not decreasing, it's increasing. And horizontal component for a projectile remain constant. Like if a projectile is launched from certain height, if the horizontal component is 3 meters per second and the vertical initially is 0, so when it is coming down, the vertical component start to increase. Like let's say it become 10, then it become 20, then it become 30, then it become 40. And the horizontal component does not change as there is no air resistance to oppose. So if horizontal is 30, all the position, the horizontal component remain 30. That is the projectile motion, the base of a projectile. That vertical component increases as it's coming down with the constant value as same as the acceleration due to gravity. Horizontal component does not change. Question 2, any doubt? Question 2, part A. What is meant by elastic deformation? There are two types of deformation, elastic and plastic. If a material return to its original shape or a size after we remove the force, we call that as an elastic deformation. But if the material does not return to the same original length, shape or size, We call that as a plastic deformation. Part B, any doubt? Part B, 1 and 2. Question 3, any doubt? Which is about the momentum B1, 3B1. In 3B1, how you will score, get the 3 marks, the velocity of the descent module can be changed using a rocket motor. The rocket motor eject the hot gases at high velocity. Explain why the velocity of the descent module changes when the rocket motor is used. And your answer should refers to a Newton law of motion. So the same concept as the rocket propulsion you have to use here. That what will happen if we use a rocket motor, that rocket motor, like let's say we are using a rocket motor. So a rocket motor will exert force on the air, like force on the gases. Like rocket motor exert force on the gases. As a result, what will happen? According to Newton third law, the gases will apply equal and like let's say this was a rocket and there was a motor here. So how this rocket can be moved by this motor? So when the rocket motor exert force on the air as it the motor rotate, so as it exert force on the air will exert equal and opposite force on the rocket according to Newton third law, and that force will cause an acceleration of the rock on the rocket. So rocket motor exert force on the air or a gases, so the gases will exert the force on the motor as a result of Newton third law. And if there are unbalanced forces acting on this, if the forces are not balanced, then this rocket will accelerate. So this was a structure pop quiz 16.